Good morning, everyone. As usual, how did the homework go? Any questions? Please put them on chat. Very nice. So we're going to do number 1 because number 2 is exactly the same, just to make sure we can compute those Riemann sum. Okay. So 3E, which prop to see from where, Oscar? Okay, 1C, I understand that. All right, we'll go over them slowly. So I start with number 1. So we have the function f of x equal x cubed, x to the power 3. Okay, and the part A is we have to estimate the integral from 0 to 3 of x cubed dx. Okay. We have to estimate the integral because the integral, the definite integral, as far as we are concerned, is nothing more than taking those Riemann sum for more and more interval. The more we get, the closer we get to the actual value. So in the first one, I'm asking you to estimate it using Riemann sum with 6 subdivision. So we're gonna use 6 subdivision. So a little bit, a small picture, and then we proceed. So that's my interval, 0, 3. My function is x cubed. Okay, that's my function. So this is f of x equal x cubed. And what we have to do is we need 6 subdivisions, meaning I need to divide my interval into 6 equal pieces. Okay, so we have to divide it into 6 equal pieces. So every piece, delta x, is going to be 3 minus 0 divided by 6. Every piece is going to be 1/2, every subinterval. So this is a 1, this is a 2, this is a half. Those are my 6 subintervals. So this is a half, a 1, 3/2, 2, 5/2, and finally 3. Okay, and what is the Riemann sum? It means my integral using 6 subdivision only, which is not a lot, is almost equal to. Okay, right? Riemann sum. It means we're going to take the value at the right endpoint of the function multiplied by delta x, which is basically going to give me the area of this rectangle. So it's the value of the function at a half times my delta x, which is a half, plus the value of the function at 1 times my delta x, plus the value of the function at 3/2 times the delta x, plus, so this is at 3/2, f at 3/2 is from here to here. The delta x is the length of this interval. So times adding the areas of those rectangles. That's the geometry of it. And then I have f of 2 times delta x plus f of 5/2 times delta x plus finally f of 3 times delta x. So that's really the Riemann sum with 6 subdivisions. Okay, let's see, this is equal to what? What is f of 1/2? My function is f of x equal x to the power 3. So f at 1/2 is a half to the power 3 times 1/2. So that's the first term. Plus second term. F at 1 is 1 to the power 3 times a half. And then the rest is easy because my function, the function I'm working with is the x cubed function. Plus 3/2 to to the power 3 times delta x, which is half. So I'm adding the area of this plus that, because my function is positive, that's really important, plus 2 to the power 3 times a half, plus 5 half to the power 3 times a half, plus finally 3 to the power 3 times a half. Okay. And now we either use a calculator or we use any program, you know, that you can find, and we evaluate this value. And did anybody do it? Did anybody actually evaluate it?
Yeah.
How much did you guys get?
27.56.
27.56. Anybody else? Okay, or somebody's giving me the exact value, which is all right, which should give us exactly the 27.56. So this is really a very rough estimate on the integral. Very rough because we actually did not take a lot of subdivision. We only took really only 6 subdivision. And from the picture, we realize that if we start adding the area of those rectangles, there is a big difference between them and the actual area under the graph. So it's really a very rough estimate. Now, in the second one question, I'm asking you basically to use a program. You know, online, you can find a lot of programs who can compute those Riemann sum to compute the Riemann sum. So it means if you take 100 subdivision, means the delta x is very tiny now. It's 3 over 100. So very tiny. And then what's the Riemann sum? Anybody was able to find that? So we should be getting now, by taking more and more subdivision, we should be getting closer to the actual value. Anybody was able? Okay, Alan got 20.66. What about for the second one? 20.45. Okay, so there's still a difference between the values. So if I am to tell you what are those, what's the actual value is getting close to, I'm still not sure. I know it's 20, but I don't know what's really after that, because I have the 20 here and the 20 here. So to be able to find exactly, you know, what's after the decimal, actually, I need really more and more subdivisions, which is not hard, as you realize once you do it on a using a program. Okay, but that's really the estimate. Very good. So this is the technical part. Now the question that you guys are asking me is 1C. Any questions? Please ask question. Don't shy away. There is no stupid question. So I see the number 1C is I want you to write the general formula. So write the integral from 0 to 3 should be x as a limit of Riemann sum. Okay, I know that the question is not very clear, but that's not a point. That's why I'm giving to you. So the idea here for me is that I want you to use the notation to write, get used to the notation. So the general formula is the following. We usually, we're taking the interval 0, 3 in general, and we divide it into n pieces. So we call this x1, x2, and this is xn. So this is equal to the limit as n tends to infinity, means when n become very large, what you're computing is the following sum. That's really what I want, no more, no less. Sum I equal 1 to n of the value of the function at xi times my delta x. That's really the general sum. But this is what in my scenario. What is my f of xi in our situation? So this is only for the notation because we need it. What's f of xi in my problem? I'm still working with this exactly, but it's not x cubed, it's xi not x cubed, it's xi because it's changing. So it's xi to the power 3. That's really what it is. The delta x, I will give you two choices. You can either keep it delta x, I will accept that, or you can substitute it by, what is my delta x when I have n subdivision? The length from here to here, it's 3. So my delta x is 3 over n. Okay. So that's really what I'm expecting you to write when I ask you to write it as a limit of Riemann sum, because I actually want you to start seeing this piece right there as an integral. I want to, when you see a sum like this, I want you to see it as an integral. That's the reason why I am a little bit pushing this idea. Okay, so be careful. This is not x cubed, it's xi, because what I'm telling you here is x1 to the power 3 times the delta x, x2, so it's changing, x3, and so on and so forth. Any more questions? Now, your other question, let me look at them. So problem number 2 is going to be verbatim the same. 3, I did not assign. So 3, we're going to work on it today, Ian. 3, yes, I'm going to work on it today. And 2C is exactly like this problem. So I will do the setup for number 2C. In 2C, we have to estimate the integral from 2 to 5, x squared minus 3x dx. So the first two questions, you should be able to do them. No, I don't think they are hard. It's how to write it as a limit of Riemann sum. So this is going to be the limit. As n tends to infinity of those following sum. Those are my Riemann sum. I equal 1 to n of the value of the function. That's the function, but at those different points. Times the delta x. The delta x in my case is 5 minus 2, which is 3 over n. Okay, so be very careful with the notation because I will be judging you on the notation themselves. This n, it means we'll sum I from 1 to n. It means we are summing over n subinterval. And this is the values of the function at those different points. Okay, today what we're going to do is we're going basically to wrap up the review for from 163, and we are going to talk about the fundamental theorem of calculus. For us, at least for now, at least forever, the definite integral is a limit of this sum. And to be able to compute it, you have to compute those sums, which is tedious, as you guys realize, and necessary a lot of time. The fundamental theorem of calculus is one of the most fundamental theorem in calculus. That's why it has this name, which gives us a tool to evaluate those integrals as long as we can find an antiderivative for the function. So it's one of the most basic tools in math, which tells you that if I can find an antiderivative, there is a simple way to evaluate this integral. It means a simple way to compute the sum, because the integral is the sum. So this is the sum that you really care about. So the fundamental theorem gives us the two. So let's see how it stays and work out a few examples relating. So and this is the part that usually students know very well. So the fundamental of calculus. What does it tell me? It tells me that we have a function f, okay? So f of x is a function. defined on an interval AB. And big F of X is an antiderivative of little f. It means f prime equal to f prime. Means if we know the antiderivative of the function, then the integral from A to B. It means this sum, this Riemann sum could be obtained as follows. It's equal to the value of the antiderivative at the upper limit minus the value of the antiderivative at the lower limit. That's just telling me if I know the antiderivative of little f, so to evaluate the integral, I take antiderivative at the upper minus the antiderivative at the lower. Right, this is the theorem. This is really, really important theorem. Is probably some of you know is due to Leibniz, the one who created the notation, and the famous Newton. Both of them at the same time were able to show or to prove that this Riemann sum we're talking about could be obtained by this simple little theorem, by taking the antiderivative at the upper minus the antiderivative at the lower, as long as we are able to find the antiderivative. And because of that, there were a lot of mathematical advances, and as a result, of course, a lot of advances in physics, because people were able to use this tool to evaluate a lot of quantities. All right. Now, a small notation, and then we just do examples. So, notation. We use the following notation. F of x, this notation, big line AB to denote f of b minus f of a. So this f of b minus f of a, we have this notation for it. So we sum it up. So the integral from a to b can be evaluated by finding the antiderivative, which is the notation is the same as f of x between a and b, where, one more time, f prime is f, or f is the antiderivative. Very powerful theorem. I mean, you guys realize how tedious it is to compute the sum, and this is really make it much, much easier. Now we're going to practice this. So, bunch of examples, lots of them. So, example number 1. The first example, I'll do it very slowly, and then we start speeding up. Evaluate using the fundamental theorem of calculus, of course, the following integral. Okay, I'll start with a simple one, as I said. Integral from, let us say, 0 to 1 of x squared plus 6 dx. So graphically, it means, I mean, I don't have to do graph all the time. This is my function, x squared plus 6. So that's a parabola going up. My interval is 0, 1. And this definite integral, because my function is positive, is going to basically represent this area. So that's really graphically what we're doing. All right, now we can compute the sum, but the idea now is to use two fundamentals. So to do that, we need an antiderivative. So let us first find the antiderivative of x squared plus 6. So antiderivative of x squared plus 6. It means what is the function whose derivative is f? So what's the antiderivative? Okay, antiderivative of x squared, 1/3 x cubed, plus, what's the antiderivative of x? Of 6, quickly.
6x.
6x. Now the constant, I will write it and then I will tell you that you don't need it. So I'm going to write c here, but then you're going to realize that you actually don't need the c, and you will see that later on. All right, so now let us evaluate the integral. The integral from 0 to 1 equal the antiderivative evaluated. So if I value between 0 and 1. It means it's the value of the antiderivative at the upper limit minus its value at the lower limit. At the upper limit, it means I plug in 1 into it. So the value at 1, it's 1/3 plus 6 plus c. Minus the value at 0. If I put 0 here, I get 0. I mean, it doesn't have to be, plus c. Okay, finally we get 1/3 plus 6, which is going to give me 1 plus 18, 19/3 plus c minus c. 19/3. Okay. Now, when we are evaluating a definite integral, the answer should be a number because it's an area. So you should not have constant in the answer when it's a definite integral. Let's make sure of that. And if you put a c when you find the antiderivative, it's going to get canceled out always, unless you're doing something really wrong. For this reason, when you're finding a definite integral and you compute the antiderivative, you don't have to worry about the constant at all, because eventually it will simplify. It has to simplify because the answer has to be a number. There is no constant in the answer because it's actually an area. So my advice to you, don't worry about the constant when you are dealing with definite integral, pure and simple. Okay. Now I'm going to do one more problem, and then we're going to do substitution and definite integral. So we're going to combine both of them so we can deal with them. But another problem that doesn't require substitution, that's just for you to practice integration a little bit. So problem number 2, and I'll give you a minute to interact with it before I proceed. Integral, evaluate the following. Integral from 1 to 9 of x minus 1 dx. So remember, evaluating definite integral using the fundamental theorem is really nothing more than evaluating the antiderivative or the indefinite integral. And then once you know the indefinite integral, you do the evaluation. So now you have to focus on this. And the question is, how would you find the indefinite integral of this function or the antiderivative? Okay, I'll give you like 30 seconds just to interact, and then we'll go on our way. What would you do to find the antiderivative of this function? Okay, I have one suggestion. Anybody else? Anybody else want to pitch in? I have one answer which makes sense. Anybody else? Split the fraction. Okay, Ben, how do you want me to do it? Can you speak? Ben, can you speak or not? I don't know. Okay. So.
Yes, I can.
Okay, so please tell me, how would you do it then? What do you mean by split?
I would put x over square root of x minus 1 over square root of x.
Okay, I will follow you verbatim, and you tell me what to do. So far, so good. We can split numerator, not denominator. So far, we're fine. Keep going, Ben.
Then you can split up the integral into 2 separate integrals.
You can do that if you want to. You don't have to. I mean, you can do it
And then-
mentally. Go ahead. I will follow you, though. You want me to split? I will split. Okay. Keep
And then
going.
I would you'd be left with x or square root of x, d of x,
What do I get? X over root x gives me what?
just x to the 1/2 power.
Right, because that's x over x to the power a half. It means x to the power a half. And this one will give me x to the minus a half. We have to prepare, because remember, at this stage, we're really just doing indefinite integral. That's why we started with indefinite integral. Okay, and now we're done. We have to evaluate this. Antiderivative is 1 over a half plus 1. It means 1 over 3 halves, which will give me 2/3 x to the power 3 half, evaluated between 1 and 9, minus 1 over minus a half plus 1, which is 1 over a half, which is a 2. So I will get minus 2 x to the power a half, evaluated between 1 and 9. Okay. And then finally, I get 2/3, 9 to the 3 half, minus 2/3. That's for this piece. Minus for the second piece, 2 times 9 to the power a half, minus 2. And the rest is actually simple math. It's 2/3. 9 to the power 3 half, it means 3 to the power 3, it's 27, I think. Minus 2/3. Minus square root of 9 is 3. 3 times 2 is 6. 6 minus 2. So finally, I would get 3 and 27. This would give me 9, 18. Minus 2/3 minus 4, which is 14 minus 2/3. And you can add fraction together. Okay. All right. Now we're going to do questions before we move on. Another thing I would like to remind you of is how we handle substitution and definite integral. So definite integral and substitution. Okay. It means, what do I mean? What do I mean by that? Because whenever you're finding, so to use the fundamental theorem, you actually need to find the antiderivative. That's really what the problem boils down to. And as we realize, to find the antiderivative, sometimes we need the substitution. So the question is that if you have to use substitution to find the antiderivative, and you have boundary, upper and limit, and you have a definite integral, how do you go by it? Now, there are two ways of doing it, which are basically the same, but with a small variation. So the first method, so there are two methods, and I hope you guys do not confuse them. The first method is we evaluate the indefinite integral first, and then use the fundamental theorem. It means we just, okay, what do I mean by that? So I'll start with a fairly simple example. Suppose I tell you evaluate the integral from 0 to 4 of the square root of 2x plus 1 dx. Okay, I want to evaluate this. Okay, so The bottom line is that I need to find the antiderivative of this function. Now, this function, the only way to find its antiderivative is by substitution. There is no other way. All right. So what I'm going to do is I'm going to find first the indefinite integral. It means I want to find the antiderivative. So we're going to find antiderivative. Right. So I forget about the limit for a split of it for a little bit, and I find the antiderivative. Right. So how do I find antiderivative? That's a typical substitution problem. Means I'm going to put u to be to x plus 1. I find du dx, which is a 2, means tu du is 2 dx. Total substitution. So this is equal to integral of square root of 2x plus 1 is the square root of u. Dx, I'm going to pull it from here, is half of the du. That's my dx. So times half du. At this stage, I'm not putting any limit because I'm after the antiderivative. That's what I am after right now. A half is a constant. I can pull it out. Integral of the square root of u du means a half. Integral of u to the power a half du. Always have to go to fractions. So this is equal to a half times 1 over a half plus 1 u to the power 3 half. Now I'm not going to put constant because I know at the end I'm dealing with definite integral. So this will leave me, I go back to x because that's my variable, 2x plus 1 to the power 3 half. That's the antiderivative. That's what I am doing so far. Now I go back to my integral. So I found the antiderivative in terms of x. Now I use the fundamental, which tell me that the integral is my antiderivative this is my antiderivative evaluated between 0 and 4. Okay, so I found it. Now I apply the fundamental theorem. And so it's going to be equal. A third at 4, 2 times 4, 8 plus 1. It's a 9 to the power 3 half minus a third, 2 times 0, it is 0 plus 1, 1 to the power 3 half. Okay, and then you just do a simple math. It's going to be a third. That's going to give me 3 squared. So I will have 27 minus a third, which will going to give me 26 over 3. Okay. All right, so the first approach is you forget about the limit a little bit. You find the antiderivative as a function of x. Once you find as a function of x, you go back to your definite integral. You use the fundamental theorem of calculus and you finalize. Now, another approach to substitution, which is the same idea, but we change the limit at the beginning. Let me make myself clear. I'm going to take the exact same example and do it again. But this time I'm going to change the limit at the beginning and never go back to x. So in practice. So another method. Okay. The other approach is once we introduce u, we change the lower and the upper limit. So I'll write it down. Change the limit. Of integration when the variable is changed. And example will make it clear. It's changed and do not go back to x. Right. Now in practice, what I am talking about. So again, I will take the exact same integral. I'm not changing. The question is, again, I need the antiderivative. And the only way I can find antiderivative in this problem is by substitution. And we know what my u is. So here, we know that my u is 2x plus 1. My du is 2dx. This is we know. Now, immediately at this stage, I'm going to change the limit. So what do I mean by that? Change the limit of integration, means the lower and the upper limit. I mean by that the following. I said that when the limit is 0, that's the lower limit, u will take the value, I substitute 0 in u. 2 times 0, u would be 1. When x takes the value 4, u would be 2 times 4 plus 1, which it will be equal to 9. So I change the limit of integration. And the idea is that, so this integral will become, and there's a theorem that tells us what we're doing works perfectly. This integral will become, the 0 will become a 1. We change everything. The upper limit become a 9. This is the square root of u. This is a half du. Okay, so what I did at this stage is that I changed also the limit of integration. And now at this stage, we do not go back to x. We're done with x now. We do not go back to x. That's it. Now u is my variable. U is my variable. I have a new limit for u. X doesn't exist for me anymore. So this is going to become equal to a half du. That's a new integral in u with new limit, no access for us. U to the power half, the antiderivative, evaluated between 1 and 9. So finds is equal to a half, 2/3 times 9 to the 3/2. And if you look very carefully, it's basically the same thing as before, but now we change the limit at the beginning. So that's a half. Now this 2/3 could be honestly factored out. And here I will be left with 27 minus 1. So this would leave me with those two, 1/3 times 26, or 26/3. Okay. So this, in the second approach, the only difference is I knew that I needed substitution. I did the substitution exactly like the beginning, but I changed the limit immediately using this way. And once I change the limit, I don't go back to x. I am done. And then I proceed as before. Right?
Professor?
Yes.
In the first question, instead of substitution, can't we solve as if it's a normal integration? Because I could find the same solution. So basically, I wrote 2x plus 1 over, no, to the 1/2. And then I make it 2x plus 1 to the 3.
Wait, give me 1 minute. The power, so you wrote this way.
Yes, the way that we did for the normal
yes.
numbers.
Keep going.
And
then,
2x plus 1 to the 3/2. And then I multiply this by 2/3. And at the same time, when we get derivation, it would be like 2 multiplication. So I divide it by 2.
Why did you divide it by 2?
Because when we take the derivative of this function, it will be multiplied by 2.
Yes, my answer is the following. This is an easy integral. All right. So,
So
you can
this is
think,
true.
right. Once the integral become a bit harder, you cannot do that. Are you
Oh, I
with me?
see. Mhm.
So this is because it's easy. You know the chain rule. You can go backwards and say, yeah, I have to divide by a half to compensate. I understand that. But once the integral is a bit harder, you can't do that in your head. So I strongly encourage you, even though with this simple integral, I want you to do the U substitution.
Thank you. I see.
Okay, that's really the reason. That's the reason. Okay, I'm not definitely attacking your intelligence because things will definitely become more complicated, way more complicated than that. All right, so we have to do it.
Yes.
So now let's do another one. So evaluate, and you guys will tell me whether you want me to do which method, 1 or 2, because you should be able to do it both ways. Integral from 0 to 1, x e to the 4x squared plus 3 dx. All right. Would you want me to do using the first approach or the second approach? And make sure you know what's the difference. Any ideas? Okay, so we're gonna do it the second way. If you guys don't tell me what. All right, so the second way, basically the whole problem boils down to find the antiderivative. And the students are already telling me, okay, when I see this, I see two things. I see an inside function for x squared plus 3, and I see this derivative, which is 8x up to a constant, which is all right, we accept that. So we're gonna introduce my u. My u is 4x squared plus 3. Then my du is the derivative of 4x squared, which is 8x dx. I'm gonna change my variable immediately. And let me be clear how we change them. Change the variable, the lower and no, change the limit. Okay. So when x is 0, the lower limit, u would be 4 times 0, which is a 0 plus 3. So my lower limit is going to become 3 now. When my upper limit, when x is 1, my u would become 4 plus 3, which is equal to 7. Now I'm changing my limit. I'm plugging in here to change the limit. I'm plugging the value of x right there. That's what I'm changing the limit. And now once I do that, I'm creating a whole new integral in u with a new limit. And that's the one I will work with. So 0 turned into a 3. The 1, we turned it into 7. I took care of the limit. Now the inside. This piece is the easy one, is e to the u. But now here I have the x dx. I go back here, my x dx is 1 over 8 du. This is my x dx. Okay, so it's become 1 over 8 du. Right, so find this equal to 1 over 8 is a constant. I need to pull it out. And I will have the integral from 3 to 7 e to the u du. Very simple integral, very simple limit. I don't need really, I'm done. Since I changed the limit, I forget about x. U is my new variable at this stage because I changed my limit. And finally, I will have at the upper limit minus at the lower limit and of the problem. Okay. Any questions? Right. Okay, we'll do one more and then definitely we stop. The last one is a little bit trickier, but not that much. evaluate the following. Integral from, I try to use easy numbers as much as I can, 1 to 4 of square root of x dx. Okay. It looks nasty, but it's not as bad. Remember, all those problems are made up for you to be able to do. All right, I'll give you 1 minute to think through it and then tell me what to do. Okay, I need to talk about my lab for the last few minutes, so please stay with me. It's important. All right, any ideas beside the one that I see on chat? Okay, David, you wrote e to the u over u. So what's your u? David?
Yeah.
What's your u? You gave me something. I'm trying to understand. What's the u here?
The u would be x to 1/2.
So u will be the square root of x. Yeah, absolutely correct. I mean, the reason we pick u to be square root of x because we want to deal with the square root of x anyway. That's one idea. I mean, nobody want to even work with the square root of x as a power. So we let u to be square root of x and actually hope for the best. That will be my approach. So it's going to be the du. That's the derivative of square root of x. So x to the power 1/2. The derivative is 1/2. X to the power 1/2 minus 1, it means minus 1/2, so it means 1 over 2 root x. So the du is 1 over 2 root x dx. I'm going to change the limit. x1, my u will be the square root of 1, which is a 1. X is 4, my u will be the square root of 4, which is equal to 2. Now I did all the substitution, and now I have to go back here and be very careful. The limit, the 1 is 1, the 4 is 2. And this is the piece I have to take care of. Now, as I said, we always watch what's really going on. So this one, actually, it's basically 1 over root x times e to the root x. So we can write it actually like that to make the substitution easy. So that's what I have inside. So what's going to be in terms of u? E to the root x is e to the u. Then the piece which is left, it means 1 over root x dx is actually in front of me right there. I can pull it from here. So this is the 1 over root x dx. So if I isolate it, 2 du is 1 over root x dx. So this is going to be 2 du. And now the problem is really, really fairly simple. So it's going to give me 2 integral from 1 to 2 e to the u du. It means 2 times u now is my variable because I changed my limit, which will give me 2 times e squared minus e. End of the problem. Okay. Questions? Yeah. So please go over the notes. As you notice that I have the lectures on Brightspace. You can go over it and you have to finish the worksheet. Now for tomorrow, it's your first quiz. So you have a quiz tomorrow. It will cover everything we did this week, which is the whole review that I want to do for 164. And with that, we finish the review. Now, something important about my lab. And you guys can ask me any question you want later on. I did a mistake at the beginning of the semester and I chose another version of the book. And this caused a lot of confusion in class, especially for those who had their access code from MA163. So after I realized this, because the first time I talked to Pearson the first time, they didn't notice this mistake. Then I had to talk to them a second time and they told me that you chose another edition. Okay, this being said, I had to create a new course. So I created a new course. And all of you, except those who registered last night, all of you has to register again. So on Brightspace, you will find the new registration form for my lab. All of you has to register again. Now, those who have access code from 163, they can use the same one and they can move on. Those who has a temporary access code, they have to get a new temporary access code. The only student that may have difficulties, and those will have to tell me, are those who bought the access code for this semester. I mean, they don't have anything from last semester. Those students may not be able to get into this right now, but they have to contact me and I will talk to Pearson and they will give them a new access code. Is that clear? So even those who registered, except those who did it last night, it means after 6 o'clock, and there are only 5 of you, the other one have to register again. I'm sorry about this mistake. Register again for the course. If you had temporary, you get a new temporary one. If you have 163, you will go right away. If you purchase one exactly for my course and you couldn't use your access code, you get in touch with me. I will talk to Pearson and they will give you a new access code. Okay. Any question? No, the quiz is, the quiz is on Brightspace. Absolutely not my lab. Absolutely not. The quiz is on Brightspace. Any other questions? Okay, so you guys will have, okay, so tomorrow I will give you the quiz and it will be, it's writing. So you will have to write it. So it's not, true and false or anything like that. You guys will have to show your work and then you will have to upload the quiz into Brightspace. So it's not like true or false or guess or anything. You guys will show you write, you show all your work, I correct it and you do it on a piece of paper and then you're gonna upload it into Brightspace and I will correct it. Okay.
So are we still meeting for class and we're doing
Absolutely. We meet for class, you ask questions, and the last 15 minutes, like 8:30, the quiz will start. Or 8:25, it depends. All right. So you have to do your homework and you ask questions and everything like usual. Any other questions about my lab? You will be given time, not exactly till 8:50. I may let you go till 9 because you have to upload things. Any other question?
So Professor, will the review questions be enough for the quiz?
Yes, everything we did, and you do your homework for tomorrow because what I did today will be on the quiz.
So if I can solve all the questions on the reviews, then it will be fine for the quiz.
Yes, including the one I will assign today. Am I clear?
The third questions, right?
Yes, yeah. Because it's all review from 163, so most of you should be familiar with this stuff. Yes, definitely. Where can we find the access code? What do you mean, Alex? If you were in 163, you should have it from 163. Alex, can you talk to me?
Yeah, it was just asking for access code for me.
Do you have 163? Have you taken 163?
Yeah, I did, but
then you
I
should
don't
use the
remember
same
the
one.
access code.
You have to use the same one. You don't have it at all?
I don't think so.
Okay, now Alan is happy to stay with us, Alan, because Alan is saying to the access code is in the textbook. It's an access card. Can you find it?
Is it like in the physical book or the online book?
No, it has to be in the physical book, right, Alan?
It depends where you bought it. If you bought it online, then it's online.
Yeah, I got the online book and I can't find it now.
Did you buy the 2-year access?
Yeah, that's what I got.
Okay, then when I contacted them, they said it should automatically just sync up. So I
Oh, okay.
don't know.
All right.
Professor, would you give us?
So, one question. Alex, did you get your question answered?
Yeah.
Okay, great. Yes, go ahead.
Will you give us a course ID to add our course on my lab?
It is on Brightspace.
Okay.
The announcement page is with the new registration. Yeah, that's the one you use.
Oh, I appreciate your help.
Any other question?